So the first question, we have a cone. So a cone has a slant height of 17. This is the slant height here, so that's 17. And the base is 8. And that's the radius. Now remember, the height and the base are perpendicular, so that's 90 degrees. So the question is, how high is the cone? So what we need here is h. And to find h, we can apply Pythagoras theorem. So h squared plus 8 squared should be equal to 17 squared, which implies that h squared will be equal to 17 squared minus 8 squared. So h will be the square root of this. And if you plug that in the calculator, that will be equal to 15. Second question, we have a cylindrical drinking glass, and it has a radius of 3. So if the radius is 3, that means that the diameter from here to here will be 6, and the height is 10. Now the question is, can a 12 centimeter long stirrer be placed in the glass so that it will stay entirely within the glass? So the longest stirrer that can fit into this drinking glass will be of this length. It will be from there to there. So basically, this is the longest stirrer. So this is the longest stirrer. And let's just say it has length L. Well, I've already mentioned that if the radius is 3, that means the diameter of this cylinder will be 6, and it's given that the height is 10. Now remember, these are perpendicular. So to find the length of the longest stirrer, we apply Pythagoras theorem. So L squared will be equal to 6 squared plus 10 squared. So L will be the square root of 6 squared plus 10 squared. If you plug that in the calculator, that will be 11.7. Now, obviously, 11.7 is less than 12 centimeters. So the answer is no. Yeah. And the reason is because the 12 centimeter stirrer won't fit. It's less than that. So the 12 centimeter stirrer won't fit because it's longer than 11.7 centimeters. Okay. Number 3, a 12 centimeter nail just fits inside a cylindrical can. If it just fits, then the length of that nail should be from here from this point here all the way to that point over there. Okay, so that it just fits inside the cylindrical can. Now, this is the nail, and it's given that it's 20 centimeters. Okay, so 3 identical spherical balls need to fit entirely within the can, as shown in the diagram. What's the maximum radius of each ball? So what we can do here is, let's say, well, let x be the radius of each ball. So let x be the radius of each ball. I mean, that's basically what you're looking at, radius of each ball. So let that be x. Now, if x is the radius of each of these balls, it means that the diameter will be twice that. So that will be 2x. And which means that the height of this cylinder from here all the way to the bottom, so that height there will be 6x, because you have 2x plus 2x plus 2x. Now remember, this is a right angle triangle. Now, if we consider that triangle there, yeah, we can apply Pythagoras theorem to solve for x. So by Pythagoras theorem, we know that 2x squared plus 6x squared will be equal to 20 squared. So basically 4x squared plus 36x squared will be equal to 400. So 40x squared will be equal to 400. So x squared will be equal to 10. Well, let me show you why. Because if we just divide both sides by 10, so divide by 40 on each side, we end up with x squared is equals to 10, because 400 divided by 40 is 10. So x will be the square root of 10, and the square root of 10 is 3.16. So what's the maximum radius of each ball? Is 3.16. If it's something higher than that, then of course the conditions won't be met. We won't have a nail of 20 centimeters fitting exactly into that cylinder. Good. So moving on to the next problem. A cubic die has sides of length 2. So that means that's 2, 2, 2, because it's a cube. Find the distance between the opposite corners of the die. So the opposite corners of the die can be this one and this one here. So basically, we are interested in that length there. So the question here is, how do we find that? Well, in example 1, the first example that I started with, I mentioned that if you want to find the diagonal of a cuboid, yeah, you can apply method 2, which is the easiest method. And what that implies in this case is d will be equal to the square root of 2 squared plus 2 squared plus 2 squared. So d will be 4 plus 4 plus 4. So d will be equal to the square root of so what happened here? So square root of that. So which will be square root of 12. Now, what these guys have said is they need us to leave our answer in surd form. So I need to simplify this surd. And if you remember, to simplify a side, you need to rewrite it so that one of the factors is a perfect square. So this can be written as square root of 4 multiplied by 3, because 4 here is a perfect square. Yeah. So this will be equal to square root of 4 multiplied by square root of 3. But you know that the square root of 4 is 2 multiplied by square root of 3, which can be written as, 2 root 3. So that is the length of the diagonal as required. So the next question is, a room is 5 meters by 3 meters and has a height of 3.5. So 5. Here's the blue one here. So this is 5, 3, and 3.5. Now find the distance from a corner point on the floor, so somewhere, let's say around here, to the opposite corner on the ceiling, so somewhere around there. So basically, the required length is that one there. Let's just call it D, like what we've done previously. And by applying method 2 of example 1, we have that distance, which is the diagonal, will be equal to the square root of 5 squared plus 3 squared plus 3.5 squared. which is equal to, you can just plug that in the calculator, and that will be equal to 6.8.